All right, classwork 2.2. Now, you need to know that the inverse function of having x to the power of n is an nth root of x. And we write the number that was the exponent in this little corner right here. Make sure that you understand when we don't write it, there's an understanding that there is a 2 there. But if this number is anything other than 2, it absolutely must be written. And you're probably familiar with seeing cube root. I want to make sure that you've got know how to say things properly. So I'm going to go over to the answers and just emphasize so we have square root of x, cube root of x, fourth root of x, fifth root of x, and then all the way down to nth root of x. And those are the opposite operations of x squared, x cubed, x to the fourth power, x to the fifth power, x to the nth power. I do want to say something really quick. I'm not going to push this on you, but understand that there are issues when n is even. When n is even, technically you have to deal with a restricted domain, like we talked about in the last unit, but I'm not going to take you there. I just want you to be aware of it. When n is even, you have to deal with issues of restricted domain and plus or minus. But again, I'm not going to throw these your way in this class. I just want to say that because technically this is only the inverse if n is odd, but if n is even, then the inverses go through that process that we looked at in the last unit. All right. Then you need to know these vocabulary words. The number that sits inside of the crease right there of that root symbol, that is called the index. I'm going to need to be able to say the index is 3, the index is 5, the index of the root is, and then tell you a number. And you just need to understand that that's referring to the number in the crease, which is the opposite of having that number as an exponent. Then the symbol itself is called the radical. The expression inside the root is the radicand. And I'm going to move over to the answers. I have them color-coded to help. So you can see the color-coded version. The radicand is anything that is in the root. All right. Now, I have found that a lot of Math 3 students don't know how to simplify roots. And so I'm going to take you through that in a slow process. So follow me. We're on a journey together with a slow process. I'm first giving you a particular situation. And I want to emphasize that this phrase is going to be here throughout this entire unit. We're not going to deal with some side issues. So just know that that's there for a reason, to make your life better. This allows you to not have to worry about the plus or minus issue. So I think you guys can do number one. Number one, what is the square root of 36? Type that in chat. Now, as long as x is a positive number, if I square it and then I square root it, what is it? And type that into chat. What do you think that is? If I take a variable x that is positive, I square it and then I square root it. Nobody?
I'm sorry, which one are you talking about? I was writing it down.
Are
you talking about number 2?
Yeah, number 2. Yeah, you got it. Does everyone see that? I've just got opposite operations going on there. There's an understood index 2. We just don't write it. Now, number 3, I want you to get to the point where you can read numbers 1 through 5 and just write the answer down. Some of you might be there, but I know that not all of you are. So I want to emphasize that if you have multiplication inside a root distributes over multiplication. Exponents and roots distribute over multiplication and division. And that distributive property works because when you have an exponent, it's repeated multiplication. The distributive property you're familiar with is if you have multiplication division, over addition or subtraction. So for example, in the past when you've had 5 times parentheses x plus 3, you distribute the multiplication over the addition to get 5x plus 15. Well, now when you have an exponent over multiplication, you distribute the exponent over the multiplication. And then that works with, on the same level, the opposite operation of exponent and the opposite operation of division in the same process. Now, that means with number 3 that you have the square root of 64 times the square root of y squared. And what I'm doing is I'm combining examples 1 and 2. And you should see that you're getting 8y. Yep, you got it. Now, I want you to see if you can figure out the answer to number 4, or the simplification of it. And if you can do it in one swoop, feel free. Does anyone think they have the simplification for number 4? If you think you have it, oh, is there a hand? I heard a hand. Yes. Was that a question or an accidental?
Oh no, you just asked if anybody thought they had it. But
oh, haha. Yeah. Okay, thank you. You're right, I did ask. Okay. And yes, that is correct, the answers that I see there. Now, if you don't see that right away, I'm going to talk you through slowly how to get there. You have multiplication under a square root. You distribute the square root over the multiplication. You know that the square root of 49 is 7. And then there are a couple of different ways of seeing that the square root of a to the 4th is a squared. Just depends on your perspective. And here's one perspective that you might see. A to the 4th is a squared times a squared. A squared times a squared is the square root of a squared times the square root of a squared. And then you have opposite operations, and you end up with a squared. So final simplification is 7a squared. And remember, we're assuming positive numbers for the variables. Another way you could look at this is to write it in fractional notation. So I want you to remember that the nth root of some number to the m power is the same thing as that base to the m divided by n. In the exponent, m is the number of times you multiply, because that's what an exponent means. And a root is really just kind of how many divisions you have instead of how many multiplications you have, so to say. And if you look at it that way, you can write this as a to the 4 over index of the root, and 4 halves simplifies to a 2. Or maybe you look at it and it just makes sense to you, and I know that happens for some people. If you don't need to show work, you do not have to show work, but understand that if you have made a mistake and you don't show work on a test, I can't give partial credit. All right. Anyone think they have number 5? And if so, write it into chat if you think you've got number 5. And hopefully you're at least looking at it, trying to figure it out, and you're not just sitting there waiting for me to do it. Based on the way that I did the previous problem, Oh, yeah. Sometimes we write things differently than we meant to. And it's hard to type it in. There you go, that one. That last one that was typed in. So now I'm going to slowly take you through it because I know some of you need it. If you don't need it, how about you look at the next classwork problem or whatever I have? Yeah, look at the next thing and see if you can figure out the next thing if you've already got this. So I want to again remind you this is multiplication, and you can distribute a root over multiplication. You should be familiar with the square root of 81 is 9. If you write these in fractional notation, you might get these faster. So I'm going to do fractional notation. The exponent is 6. The index of the root is 2. And then for the y, the exponent is 8. The index of the root is 2. 6 divided by 2 is 3. 8 divided by 2 is 4. And if I don't write the multiplication, it's understood if I don't write the symbol for multiplication. And I would say that this is the easiest way, I think, to do it, but we all think differently. So maybe to you, it's easier to look at x to the 6th as how many x squareds do I have? Under that root. And I have 3 of them. And then here, how many, because this is an understood index of 2, how many y squareds do I have? I have 4. Now, with this first type, this was dealing with expressions that are perfect squares that come out super nice. We, however, need to deal with when it is not a perfect square. So, just the number alone, that's where we're starting. If you have the square root of just a number, but it's not a perfect square number, you need to maybe do a factor tree. And I want to say again, if you can do this in your head, feel free to do that if you can quickly come to the answer. Now, 75 is like having 75 cents, which means you have 3 quarters. 3 times 25. Maybe you recognize that 25 is 5 squared. Now, if you look at those together, you can see that that makes this the square root of 3 times 25. You are allowed to distribute a root over multiplication. And the square root of a perfect square number, 25, is 5. But to avoid accidental mistakes, bring that 5 in front of the square root. And I want to make sure that you guys are very, very, very clear because people can mess this up. I'm going to write the answer in some different ways just so you see the issues of notation. We're supposed to write it without that multiplication symbol, but I have learned to write this multiplication symbol on tests because some people will accidentally read this as the 5 being the index of the root. And that's not what it is. It's easy to accidentally see it that way. Also, if your own personal writing is difficult to read, like you're a little bit sloppy, over a few steps, that can all of a sudden change. Do you see this morphing? I've seen that happen on too many tests. Be careful. If you need to write this multiplication symbol to make sure that you don't make this error, do so. I want you to understand that if you read a textbook type of answer, it's going to be written this way. That means the same thing as this, and you may be better off writing it this way to not make these silly errors of something kind of floating around and all of a sudden it's where it's not supposed to be. Okay, now x to the 9th power. One way of looking at it is the index is the number 2. So you're really looking at how many x squareds do you have. X to the 9th is x squared times another x squared times another x squared. Let me see, we've got, so far we're up to 2 plus 2 plus 2 is 6, 8, oh, and 1 left over. There are 4 x squareds. So each one of them is going to have its square root taken and be an x. So you've got x times x times x times x times, oh, I'm sorry, you're stuck under the square root because you don't have a partner. Now, I want to point out again how easy it is to mix notation up. And I really wish they would just have come up with different notation in the first place to not mess with you guys who are trying to learn math. Be careful of this looking like this because that's different. And you may be better off if you write this as x to the 4th multiplication sign square root x. In fact, I'd recommend that you write your answers that way to not accidentally have notation mistakes. And I believe I put a note in that in the classwork answers, but I'll show you that in just a bit. If you don't like doing it the way I just showed you, let me show you another way. Understanding that the index is a 2, write the fractional form. And then write the improper fraction 9/2 as a proper fraction. So what is 9/2 as a proper fraction? As a proper fraction, two goes into 9 4 equal times, but that's only 8, and I have one more. And then if you write it as a proper fraction, you can then use the fact that a proper fraction is really just saying this whole number plus this fraction. And when you're adding in an exponent, that is the same thing as two separate writings, and you are multiplying them together. So remember, that's an exponent rule. And then if you're writing it in root notation, you would write it this way. Now, here's something I want you to understand about my expectations. If I'm not clear enough on a test as to the format that your answer should be written in, then simplification-wise, honestly, any of these could be considered a simplified format. So I need to make sure I'm clear to you what kind of form I want your answer to be written in. This would be considered simplified square root form. If I don't specify that I want you to simplify your answer into a simplified square root form on a test, I haven't clarified enough to you to expect that simplification. But if I do state to simplify and write the final answer in simplified square root form, then you need to make sure to write the answer in this manner, which, just to make sure we are clear, this is the textbook way to write it, which you can write it that way. Just be careful not to accidentally write it this way. If you want to put that multiplication symbol in, that is fine, because honestly, I wish they had done that with notation, because it confuses people to not write it that way. Okay. Now, let's bring it together. If you have a number and a variable to a power together, you can look at the two separately. And I think most people do a better job if they look at them separately. We can separate because this is multiplication under a root, and I can distribute a root over multiplication and look at the number by itself and look at the variable to a power by itself. For the number, you've got to break it down. You've got to look at, okay, 20 is what times what? If you see it fastest, you'll go, hey, 20 can be divided by a perfect square 4. And 4 times 5 gives me 20. If you look and keep an eye out for perfect square divisors, you might go through the problem faster. But if you don't see it, maybe you start off with 2 times 10. And then 10 is 2 times 5. And then when you look at it all together, you can either see it as the square root of 4 times 5, or you can see it as the square root of 2 times 2 times 5, And then the index is how many times you're multiplying. But while everyone thinks differently, I think for most people it's easiest if you see it this way. I should add that on. So the number by itself is 2 times the square root of 5. Then I need to deal with the variable to a power. With the variable to a power, you can write it as a fractional exponent. There's an understood index of 2, so that means 13 halves. What is 13 halves as a proper fraction? Two goes into 13 6 whole times with 1 left over. So that means that this is y to the 6th times y to the 1/2, because again, this is actually 6 plus 1/2. And you would then write it as y to the 6th and then square root of y. And then let's bring that all together. The things that come out of the square root are written outside the square root. But some things don't have a partner and they're left under the square root. And if you want to put a multiplication symbol right here so that you don't accidentally look at it later and think that you have an index 6 going on, put that multiplication symbol. And again, I recommend that you do put the multiplication symbol, especially if you're not typing. Okay. Now, my alarm for 10 minutes left just went off, which means, unfortunately, you may have to watch this video a little bit later today. Because when you leave for lunch, I'm going to keep recording this video and finish this up. So I'm sorry, but you may have to look at that. However, I do have the typed up answers, and if they make enough sense, you don't need to watch the video. Okay, I'm going to erase this, and I'm going to go a little bit faster because we are running out of time. You can break this up into the square root of 162 times the square root of x to the 5th times the square root of y to the 8th. 162 isn't exactly what people want to see, but you can, a little bit at a time, break it down. It's an even number. I will often start there, and you can grab a calculator. If it's even, I can divide it by 2. When I divide it by 2, I get 81. And if you know your perfect square numbers, you realize that that's as far as you need to go. So the number under the square root turns into the square root of 2 times the square root of 81, which is then 9. And we usually write the number that comes out of the square root in front, but know that it's not the index, it's multiplying. For the square root of x to the 5th, if you write it as the fractional exponent, the index is understood to be 2. So 5 divided by 2. 5 halves, written as a proper fraction, is 2.5, which is 2 plus 1/2, which means this is x squared times x to the 1/2 power, which you would write as x squared times the square root of x. And then lastly, the square root of y to the 8th is y to the 8 divided by 2. And then you go, oh, hooray, that's just a 4. And you're done. When you bring it all together, the things that simplify nicely. The things that come out of the square root are written on the left. The things that are not able to come out of the square root just are stuck under there, and so you write them under there. Now, we've got 5-6 minutes left. And now I'm going to begin to walk you through cube root to make sure that you understand the difference. When the index is 3, it's asking what number multiplies 3 times to give you 125. So I'm going to put question mark, what multiplies 3 times? So some number to the third power gives you 125. What is that number? What number will multiply 3 times and give you 125? Right. The answer is just flat out 5. Boom, done. So this letter C is when you have everything is going to come out nicely. Part D, you're going to have to watch the video for. And with that, it's how to deal with it, breaking it up like we did with part B, but with cube root instead of square root. If it's coming out all perfect, if you write the variable with the fractional exponent, so the power and then the index, and then 6 divided by 3 is 2, you're done. And I'm just going to repeat that x is only going to represent positive numbers, whether it's relevant or not. The variables are all representing positive only. Now, for number 12, you're dealing with the cube root of 64 times the cube root of x cubed times the cube root of y to the 12th power. What number multiplies 3 times and gives you 64? Four. And you have a calculator to help you out with that. Then, if the power matches the index, they're just inverses. And then, if you write the fractional exponent, 12 over the index, you end up getting 4 times x times y to the 12 divided by 3 is 4. So that's if everything comes out perfect. You can stay with me for 2 more minutes to see how to get these going. With cube root, I'm again looking for a number that multiplies 3 times. So I'm going to factor tree my 40, and do stay, lunch has not started yet. 40 is an even number. I divide it by 2. 20 is even. Let's divide it by 2. 10 is even. Let's divide it by 2. 2 shows up 3 times. That means that this is this number that is showing up 3 times times the cube root of whoever was not able to show up 3 times. Know that if you read this in type print, it will look like this. But I'm going to continue to put a multiplication symbol there to make sure that you are clear 3 is the index. If you're dealing with just the variable, then rewrite it as fractional exponent power over index, and then write that fraction as a proper fraction. It almost goes in 4 times, but not quite, so it goes in 3 times. And 3 times 3 gives me 9. I have 2 more left, so it is 3 plus 2/3. That means that what I actually have is x to the third power times x to the 2/3 power. But if you are going to write it in simplified root notation, then you're going to take the denominator and make that a root. The textbook notation would look like, if you see it in a textbook, you're going to see it written like this. But for the sake of the visual not messing up the notation, I'm going to write the multiplication symbol. I've got one more to go, and then simplifying with fractional exponents. And if you need to leave for lunch, you can, and you can finish watching the video later. I'm going to break this up between the number and then each individual variable. I'm going to actually start with the variables this time. If I write this in fractional notation, this would be to the 5/3. The next one would be y to the 7 divided by 3, and z to the 2 divided by 3. You want to look at the proper fractions. 5/3 written as a proper fraction is 1 2/3. 7/3 written as a proper fraction is 2 1/3. And 2/3 is already a proper fraction where the numerator is less than the denominator. So when I go to write these in root notation, this means I have x to the power of 1 times x to the power of 2/3. Y squared times y to the 1/3. And then already a proper fraction. But when I go to write it in simplified root form, I don't want to have a fractional exponent. I'm going to write x without writing the 1, and then cube root of x squared. Cube root of y, cube root of z squared. For the number, that may end up taking you a little bit longer because you've got to break down the multiplication. If I notice a number is even, I'll start by dividing it by 2. And you can use a calculator. 54 divided by 2 will give you 27. And then hopefully you recognize 27 as at least seeing it as 3 times 9. Or maybe you automatically see it as 3 cubed. So if 3 is multiplied 3 times, then that means that this is The 3 comes out of the cube root, the actual number 3, not how many times it's showing up, times the cube root of what didn't come out, 2. Then bringing all of this together, I have 3xy squared times what is stuck under the cube root is a 2, an x squared, a y, and a z squared. And then that would be considered the simplified square root form. Last, the best way to do these problems is the root first, and I'm only giving you problems that are nice, so to speak. So you can start with the denominator is telling you to do a square root of 16, but you're going to then put that to the third power. Square root of 16 is 4. And then you can use a calculator if you need. 4 times 4 times 4 gives you 64. Root first will make your life better. This is the 4th root of 81, and then cube that answer. 3 is the number that will multiply 4 times to give you 81. 3 multiplied 3 times is 27. And then over here, do the cube root and then the power. 5 multiplies 3 times to give me 125, and 5 squared is 25. I hope that helps, and that's the end of the classwork.